Except they weren't called shade balls at the time.
This product existed, and they were called bird balls. And they used it on ponds that had mine tailings where they didn't want waterfowl to go in and get poisoned, and also around airports where there were ponds and they wanted to keep the waterfowl off so that they didn't take off and get into jet engines. You know, they'd actually done wind tunnel testing and they had, blew 50, 60 mile an hour winds across to see how they'd behave. But they were really made to deter birds and wildlife from sitting on the water.
Did there used to be birds landing here more?
Absolutely.
Yeah?
Yes, yeah.
Now, if you're concerned about the world ending in an asteroid impact, let me set your mind at ease. There are many other potential global catastrophes summarized in this map of doom made by my friend Dom over at Domain of Science. So if you want to see which of these horrible scenarios is likeliest to be our downfall, well, go check out the video on his channel.
So when they hit the aerogel, because the aerogel's a very low density material, very, very porous material, the particles actually enter the aerogel, and as they travel through the aerogel, they basically break apart the network that makes up the aerogel, and they lose energy in the process and eventually come to a stop. This is good for capturing particles because if a particle like that were to hit a solid surface, then it just stops, immediately.
And just vaporizes.
And vaporizes.
So should we expect to see aerogel in our everyday lives anytime soon?
One of my running jokes is when they build skyscrapers in Antarctica, they'll use aerogel as thermal insulation.
Recently, some friends of mine went to the Gordon Dam in Tasmania, which is 126.5 meters or 415 feet high. Then they dropped a basketball over the edge. You can see that the basketball gets pushed around a bit by the breeze, but it lands basically right below where it was dropped. Now watch what happens when they drop another basketball, but this time with a bit of backspin.
Whoa, look at that go! That's incredible.
You want those to get back in the water, do you?
This is Brett who just threw it. I literally just dropped it with a bit of spin, like I didn't even throw it and it just took off, like we had no idea that was going to do that.
And this is the most dangerous problem in mathematics, one that young mathematicians are warned not to waste their time on. It's a simple conjecture that not even the world's best mathematicians have been able to solve. Paul Erdős, a famous mathematician, said, "Mathematics is not yet ripe enough for such questions." Here's how it works. Pick a number, any number. 7? Good choice. Okay, we're gonna apply 2 rules. If the number is odd, we multiply by 3 and add 1. So 3 times 7 is 21, plus 1 is 22. If the number is even, we divide by 2. So 22 divided by 2 is 11. Now we keep applying these 2 rules. 11 is odd, so we multiply by 3, 33, and add 1, 34. Even, divide by 2, 17. Odd. Multiply by 3, 51, add 1, 52. Even, divide by 2, 26. Still even. Divide by 2, 13. Odd. So we multiply by 3, 39, add 1, and that's 40, which is even. So we divide by 2, 20, divide by 2, 10, divide by 2, 5. Odd. Multiply by 3, 15, add 1, 16, divide by 2, that's 8, and then 4, 2, and 1. Now 1 is odd, so we multiply by 3 and add 1, which equals 4. But 4 goes to 2 goes to 1, so we're in a loop, and the lowest number is 1. Now the conjecture is this. Every positive integer, if you apply these rules, will eventually end up in the 4-2-1 loop. This is commonly called the Collatz conjecture. Now we've tested by brute force all numbers up to 2 to the 68, and they all obey the Collatz conjecture. And you might be thinking that, well, we should have found a counterexample by this point. But on the scale of all numbers, 2 to the 68 is nothing. I mean, the Polya conjecture, proposed in 1919 by George Polya, asserted that the majority of natural numbers up to any given number have an odd number of prime factors. The conjecture was eventually proven false by C. Brian Hasselgrove in 1958, when he identified a counterexample. What's remarkable is the value of this counterexample was 1.845 times 10 to the 361. That's some 10 to the 340 times bigger than all the numbers checked for 3x plus 1.
What?
So this was about almost 1,000 Celsius, but behind this thin layer of aerogel, my fingers are just warm.
Yeah, it's at 31 degrees.
Wow.
Are you a believer?
I mean, it is clear this stuff insulates. This video is about taking aerogel's extraordinary properties and improving on them. For example, I'm about to step into this pool without getting wet. I think there's a layer of air there right next to my skin. That thin layer of air is what makes my skin look silvery. Light from certain angles reflects off the water-air interface in what's called total internal reflection. That is very strange. This is a really cool effect. I mean, just besides the fact that I'm basically waterproof. I feel like this extra air on me is making me more buoyant than usual. Let me try coming out of the water and see if I'm still dry. That is trippy. I don't really feel wet at all. Can I hold it?
Only if you promise to be really, really careful.
I promise I will be so incredibly careful. I will be incredibly careful with it.
Okay.
I promise.
All right. So it's slippery. Be careful.
All right. Are you ready? I'm about to touch a 1 kilogram sphere of silicon-28 atoms. There are about 2.15 times 10 to the 25 of them. Oh. It feels absolutely incredible. Wow, that is amazing. Besides its creators, I am one of only a handful of people ever to hold this sphere. The raw material used to make it was worth 1 million euros, but now that it has been so precisely sculpted, how much is that worth?
It's priceless. This you are looking at now is the roundest object in the world.
How can you say for sure that it's the roundest object? I mean, the Earth is pretty round, isn't it?
If this was the Earth,
If this were the Earth, then the highest mountain and the lowest valley would be...
about 14 meters apart.
That is shocking. That is shockingly round. But Midgley was tasked with creating a safer alternative, and in 1928 he developed a non-toxic and non-flammable refrigerant, dichloro-difluoromethane. GM called this new product Freon, and to demonstrate Freon's safety, during the unveiling at the American Chemical Society, Midgley inhaled a lungful of this gas and blew out a candle. In the following decades, CFCs like Freon became very popular and were used as solvents and aerosols. The problem is CFCs are light and stable. When released into the atmosphere, they climb up into the stratosphere, where they can remain for 50 to 100 years. But if a CFC molecule is hit by an ultraviolet photon of just the right energy, it breaks apart, releasing a chlorine atom. And this chlorine atom can then react with ozone, breaking it apart into chlorine monoxide and oxygen gas. The result was another environmental disaster, the hole in the ozone layer. With less ozone, more UV light penetrates the atmosphere, increasing the rates of skin cancer and cataracts. Plus, CFCs are potent greenhouse gases. Per kilogram, they produce 10,000 times more warming than CO2. The historian John McNeill wrote that Midgley had more impact on the atmosphere than any other single organism in Earth's history. An agreement to phase out CFCs, the Montreal Protocol, went into effect in 1989, and the ozone layer is now showing signs of recovery, although it'll take many more decades to fully recover. In 1940, at the age of 51, Midgley contracted polio and became physically disabled. So to help him get up, he devised a mechanical bed controlled by a series of ropes and pulleys. On November 2nd, 1944, while using the contraption, he became tangled in the ropes and died of strangulation. Thanks to the work of Claire Patterson, it became clear that the lead in our environment is not natural. Burning lead in combustion engines spread the toxic element across the planet, into the air, oceans, the snow at the South Pole, and even our bones. Japan was the first to ban leaded fuel in cars in 1986, but other countries soon followed suit. Algeria was the last to do so in 2021. The UN calculates that the elimination of lead from gas saves over 1 million lives per year and $2.45 trillion. But leaded gas is still used, by the way, in piston-driven airplane engines. That's now the largest source of lead emissions into the air in the US. You will observe with concern how long a useful truth may be known and exist before it is generally received and practiced on.